Good morning. Good morning to all of you. Good morning to all of you. Probably you have seen the video about stack using dynamic array and using linked list. If there is any doubt regarding these two, also regarding this stack using array, there is any doubt related to those topics, please ask. Have you at all seen that video? And the important structure of that video, the that video is that is dynamic array. Using dynamic array, how the stack can be implemented, because you don't know the size of the stack at the time of implementation. So if you define a stack memory like this using array, so if it is 100, if the 100 more than 100 data are required to push into the stack, then you cannot do this. So dynamic array implementation, or sometimes linked list implementation, is very important to uh, cope up with those data structures, right? So can anyone tell me, if you just write down yes if you understood this dynamic array implementation for implementing stack? Can anyone tell me? Okay, well, one question is Gaurav Kumar. If you need only 20 elements to be entered, then we have to make an array of 30 elements, so it is not the wasting of memory. Yes. But no. Actually, we are talking about the big size of data. Suppose every time you are uh, inserting data, that means when 16 data are already inserted into that, already pushed into that stack, after that when 17th data is coming, then it is doubled, then it is size will be 32. That is your, that means basically, uh, definitely it is depending on the behavior um, uh, of your client's need, and what type of behavior is there. The more pushing data will be there in the behavior of that organization, then definitely the waste of memory will not the concern about your, for your designing these things, right? But if you declare that only 30 to 20 elements are there, so directly you just define the array of 20 elements, no problem. But as if you are knowing about the organization's behavior, that all maximum time the pushing will be done into the stack. Now you see this, what is the, I'm giving you one example that will be, are only just you see this. So that means with the help of dynamic memory, dynamic array, you can increase the size every time. When the overflow occur, then the size will be double. right? But what is the limitation of that size? That is only limited by your RAM size, main memory size. If your memory size is 32 GB, or suppose it is more enough, 32 GB, then it cannot exceed, the stack size cannot exceed 32 GB. Definitely not 32 GB. Some memory in the RAM will be needed for operating system and some more applications, right? Application software and system software. And rest of the memory will be for you, but that is the only limitation of the stack size, right? So dynamically you can define the array if the behavior is like that, but otherwise you cannot do this. If you know that the data is static, you can do this by defining the whole array at a time, right? So depending on the push operation, the ask your client what is your behavior and try to understand what is the behavior of that organization. So now just I'm giving you one example. Um, for programmer point of view, compiler has been compiler is a system software, and compiler and operating system both will be the responsible softwares for taking care of that recursion. Actually, when you are using a recursive formula, then actually stack will be used, because every time the function calling will be there. Recursion means the function calls itself. One function is called by itself. That means every time. So where it will be stored? Where is the tracking of those addresses? Because you have to go back to the final one. Because if you want to find out the Fibonacci number, fourth Fibonacci number, then fourth Fibonacci number you can get by adding F2 and F3. But you don't know F2, F3. You have to go to you have to derive F2 again. That is F0, F1, and F3 again, F1, F2. Again you have to F1, F2, and lastly, ultimately, you are knowing about the data that two base values, that is F0 and F1, are knowing to you. That means you have to go to that base level, and those value will be returned to the previous called functions, right? Ultimately, you will get the value of F4. That can be taken care of by the stack. The how many times user will take care of this number of what will be the user input for your program, that is not known to the operating system or compiler. So in that case, dynamic array is more efficient than the static array, right? Because it is only dependent on the user. User can find the fourth Fibonacci element, or user can ask for the 100th Fibonacci element. You don't know. That's why uh, there is no waste. So depending of your organization's behavior, for whom you want to design this, you either you use static array or you use dynamic array, right? So nothing is good. Definitely, some checking will be there. That will be done manually and by interviewing the organization clients organization, right? Is it clear, Gaurav Kumar? If it is clear, then say yes, right? Okay. Any more questions, please? And you see, dynamic array is so nice of you. That means actually by doubling this size, the size will be actually operations will be just twice n. So for on an average, the push operation time is 2. That is order of 1 actually. That is very nice thing. But if you will do this linearly, 1, 2, 3, like this is order of n square, that even average is order of n. Actually, stack and queue are designed in this way that every person will take order of 1 time. Then it is helpful. Okay. Any more questions? One question just above, sir. Gaurav, any more question? Achha, you have written here, na? Gaurav. Acha, sir, how complexity changes to order of 1 when we are pushing through head? Oh, okay. But it is the question for this is the only question. Okay, okay. I'm telling you. When pushing through head, so head always for a linked list that I am telling you the details. Slowly. For a linked list, one head pointer will be there that will be stored always for defining a linked list. When you are defining a linked list, that means some nodes will be there, they are interconnected, and definitely starting address will be stored somewhere so that you can start traversing the whole linked list from that very head position. It is clear to you. This is the basic structure of a linked list. So if you know the address of the first node with the help of that head node, then if the new node will be coming, just define the new node, and the new node address will be stored into the head address, and the first node's address will be that has already been stored in the head address, that will be coming to this new node link part, right? That means there is only two copies will be there. The new node address will be copied to head node, and head node address will be copied to new node. That means only one insertion, for one insertion only two copying operation will be needed for that insertion from the head, right? That's why you are it is order of one. Two copies means this is order of one, that is fixed for every time. If you want to insert any number of elements, always for one element pushing, only two copies will be needed. That is clear. But if you do the pushing operation into the tail, then what is the problem? Push or pop? You have to traverse. You can tell that, sir, if I always store in some variable that the last node's link, then you can do this. No, you cannot do this, because if you can store the last node link, then after popping the element, you cannot go back to that the previous node, because this is a singly linked list. What I have told already, this is a singly linked list. That's why you cannot go back. If it is a doubly linked list, definitely it can. I don't know whether it has been covered or not, but definitely it will be covered. If it is not covered here, after some time it will be covered, or in second year it will be covered, right? So there is a concept of doubly linked list. That means you can go from the head side to tail, and from tail side to head. That means everywhere there is a two link part. You can traverse from the left to right or right to left, right? Then you can push and do the push and pop option from the tail, right? But when you are implementing through singly linked list, it cannot be done, and it is order of one when it is only coming from this push up from the push operation or pop operation from the head side. And you just see one thing: pop operation can only be done. Suppose pop means you want to pop one element from the head side. That means the first node will be popped. What does it mean? It means basically uh, the second node, that means first node link part, will be copied to head node, because that link part will address to the second node. So that link part will be copied to head, means automatically the connection of the first link will be disconnected. That means the head is now pointing to the second node. That means for pop operation only one copy will be needed, and for push operation only two copies will be needed for every push operation. That's why the pop and push operation through head side, it will take only order of one time. Probably it is clear to you. Uh, is it clear, Gaurav? Gaurav, is it clear? Is right? Yes, if it is clear. Otherwise, I will tell you again. No problem. Yes. Okay. Any more questions? Actually, no other students are there who will ask any questions. It is very nice that everyone have understood that topics clearly. Right. Hitesh Bhagat, it is clear, sir. Saurabh, like, how will practical exams be conducted? Probably practical examination and theoretical examination. There will be uh, viva also for practical examination. Probably no implementation part will be there. Possibly that will be notified. Only viva will be there for everyone. Right? We will take one viva for theoretical and of theory and one viva for practical, and based on that, we'll give you some. There will be some marking system. No problem. Okay, so probably it will be notified. What is the ultimate decision? I'm not knowing about this. Written viva or oral viva? No, oral viva. Till last day, it is decided that it is viva is purely oral person. Right. Soumyajyoti Ghosh. Soumyajyoti Ghosh. Why have you written thank you, sir? And there are two meanings of thank you. You don't you don't ask any question here. Thank you, sir. Means you can go. You are no more needed. Or thank you for sorrow likes question. I don't know. There are the two cases. Any more questions, please? Shotto Prakash, I'm telling you, you have understood that video clear every step. Acha, one thing I want to tell everyone who are viewing this, some of you definitely started this and written your name in the chat and just not hearing anything. Okay, now, I am telling you one thing that this procedure is this jumping procedure like a GP series 1, 2, 4, 8, 16. That GP series jumping is more important structure for many of the situations, right? Because after 2 power j, uh, j will be a basically log n, right? That log n structure is very much important, right? Can anyone tell me what probably you have learned this stack thing? So what is the real-time application of stack? Just idea. If you are knowing about this, then please tell me. Or if you don't know, then think for 1 minute. What should be the application of stack? Already I have told about this. The recursion. In recursion, you can use the stack. Otherwise, what is the application of stack? Can anyone tell me? After completing lowdown, I will give you the chocolate. Who will answer this? Reverse a word. Reverse a word with a. No, it is not necessary. Reverse a word. Uh, what is Shobhi Podar? I want to know what is cryptocurrency and bitcoins. Bitcoins how it is reversing something. Anmol Raj, language processing, Satya Prakash. These are actually the application of stack is the reverse of a word. Why the reverse of a word stack is needed? Word is stored in a linked list. Word is stored in a linked list or array. If it is an array, the reversing is very easy. You don't need stack. But just I'm telling you, the stack is necessity. Stack is a necessity for implementing recursion. I want that type of example. Now I'm giving you one example that Acha, Shobik Poddar and Shobik Poddar, I don't know about seriously. I don't know about bitcoins and cryptocurrency. I want to learn from you. Bitcoins and cryptocurrency. Probably this is something. It is the topics of blockchain. Am I clear? Am I telling wrong? Parsing the syntax also is right. One thing, why nested for loop? You are using braces. You are using braces. Then that means opening brace and closing brace. Number of opening braces and number of closing braces should be equal. Well, here the stack must be needed. Again, another thing, when you are writing one expression, mathematical expression, then it will be converted into a postfix expression that I will tell you later on. Some of you definitely are knowing about this, and then the stack will be needed, right? First and then the second last edit. Acha, edit. A stack is an abstract data type that serves as a collection of elements with two principal operations: push, switch, correction, and pop. We remove the most recently used. Utsavraj, why are you defining stack? It is definition is key, correct, but I'm not asking you the definition. I'm telling you the what is the application. Acha, yes, it converts. Right, right. And the third last and so on, so right. So many stack applications will be there now, and you are already knowing about what Dibusri ma'am has covered probably, that is Tower of Hanoi problem. Towers of Hanoi problem. That is where to solve this problem, stack is needed. I'm asking you one question, probably for recursion. The recursion thing is covered in one class only. Probably I'm or in one section probably. But I'm asking you for finding Fibonacci number. Suppose we want to find out the 100th Fibonacci number, then recursion is will be helpful or iteration will be helpful. Can anyone tell me the answer? Recursion is helpful or iteration will be helpful? Hmm? When you want to find out the recursion, actually top-down approach. Stack means when you are using stack to implement the recursion, then it is actually recursion will reduce the time complexity. Are you sure, Anmol Raj? I mean, the way Control Z works. Show the brain. Nice. Right. Good example. DSG. Who is DSG? Right. So I think addition, because in recursion we will be taking up huge amount of memory by calling the function continuously. No, you're so big. I'm telling you, not helpful for 100. Yes, I'm telling you one thing. So everyone, just when you are finding F4, just simply think this. F4 means it can be gotten by adding F3 plus F2. Again, F3 is equal to F2 plus F1. That means you see this. If there are
There is one call for F for finding F4, that is F2, and another call for finding F3, that is F3, F1. That means so many overlapping calling will be there. If you can design an algorithm to store, suppose you are finding F2 first. Now, after finding F2, if you can store F2 somewhere so that it can be used from that stored area, no computation will be needed. Further computation will be needed. But here you see, when you are using this using stack, then actually so many repeated things will be there. That means overlapping function calling will be there. So what is the tree structure? You can see if 100 means if 99, if 98, again 99 means 98, 97 like that. So this is a tree structure. You see this tree is going from 1, it is the child number is 2. For 100 it is 2. From the first level, the child number of child is 4, then 8, then this is the power. That means basically how many calculations will be needed. This is 2 power 100 approximately. But if you are doing by iteration, then start from F0, F1, you will get F2. Then if with the help of F1, F2, you will get F3. That means only one calculation will be needed for every step. It can be done in linear time, but when you are applying the recursion, then definitely using stack means more memory will be needed, definitely, but time is also on the high. It cannot be done less than exponential time, that is 2 power n. If you want to find Fn, it cannot be done less than 2 power n. If you use this top down approach, means from F1 you are going down, Fn minus 1, n minus 2, like up to F0, F1, right? And then it will return the value from F0, F1 to go back to Fn. So top down approach for recursion, that means it will go top to down and then back from down to top. But iteration means it will directly go from bottom to up, means down to top. That's why its complexity is order of n when you are doing iteration here. But sometimes some problems are there where recursion will give you the good coding system actually. For the coder, the recursion will help you more. Only by doing the parameter passing, it will reduce the work of a coder, right? But always you think for that whether it will give you, it will increase the space or increase the time complexity or not, right? So that's why Anmol, this is not good for Fibonacci number, right? Okay, it's clear. Any more questions, please? Tree recursion. Archishman Raichodhuri. Tree recursion. Tree. What do you mean by tree recursion? Archishman Raichodhuri. Archishman, I want to listen from you that what is tree recursion? Oh, you want to tell for Fibonacci number recursion, that is tree recursion? Definitely, it is a tree recursion. I'm not getting, sir. Is it better Q FIFO stack? Which is better, Q and stack? No. It is not a good question. But sometimes Q is better. Q and stack are two different data structures. Am I clear? Q means first in, first out, and stack means last in, first out. Whenever for solving your problem stack is needed, use stack. Otherwise, use Q, because in Q, inserted from one side, data will be inserted from one side and will be deleted from other side. But every operation is of order of 1 complexity for Q, for inserting and deleting. And for stack, it is also order of 1, and for push and order of 1 for pop. So nothing is better than anyone. So Q and stack are cannot be compared, right? So whenever Q is needed, do this. Whenever stack is needed, do this. actually where the queue application will be there. When you are scheduling some processes into a computer, some memory, only the few resources will be there, but more processes will be coming. You have to stand into the queue, right? But within that queue, if there is a priority element, priority process, that can be checked by with the help of another data structure that is called priority queue, that I will tell you later on. If first you have to learn the queue, that is, if the job is higher priority job, that can be done first, right? This is the more important thing that I will cover later, but it cannot be compared. Acha, Orchis manage an iteration method which is in the form of a tree where at each level nodes are expanded. Take right. It is like a tree structure, but actually you see, it can sometimes in what I have told already, Ashisman. You see, uh, if you can do this with the help of not a tree, if the graph can be formed, I don't know whether you are knowing about the graph or not. Graph can be formed means when you are writing F4, F3, F2, and here F4, F3, F2 again is there. That means if it is a graph structure, then write F2 only once. That means somewhere F2 will be stored in some places, and whenever it is needed, it call from the stored place. Just call that data, not the call the computation. Call the data only. Just copy that data and put it in, because computation means it will go to the ALU. That will take much time, right? So it is a tree structure. If you do this with the help of graph, then it will help you, and it can be done. Later you will see. If you want to do the advanced study, you can do this. It is available in internet everywhere. It is available. You see this. I am telling all of you. I am requesting to all of you that. Actually, Diptangshu Gupta, is it clear to you? Q, which is better, Q and stack? It is clear though. Those two terms are not comparable. These two are of same complexity, but different usability, right? Okay, nice. Actually, binary search can be done with the help of regression, right? Only few more spaces will be needed, but here the complexity will not be increased. Why it is not be increased? Can anyone tell me? I'm asking to all of you, please, who are already now watching. Sir, how can we reverse the stack efficiently? How can we reverse the stack? Reverse the stack means, no, actually, stack cannot be reversed. Stack is is a data structure, right? Better you can tell this how with the help of stack one string can be reversed. It can be. It is a good question actually. Uh, तो रिवर्स ऑर्डर स्टैक में डेटा है तो उसको रिवर्स कर दो, निकाल दो एक एक करके, निकाल के एक एरे में स्टोर कर दो. Actually stack can be reversed. If you are using if you are implementing stack using array, then actually you can um, write from the front side to left to right, or you can write from right to left. So this question has no meaning actually. You don't need to do the reversing, because you are defining the stack in this way that we can do this operation from this side only. But actually array is there. You can write from the left side to right or right to left. So why the stack is needed? Right? So this is the answer. Acha, right. Actually, you can tell that how can we reverse the stack efficiently. You just take another stack and pop from the previous stack and insert into the and push into the new stack, and that will give you the reverse of the stack, right? And if you are using array, then you don't have to do anything. You just read the data from ulta side. Just if it is in the if in the array, suppose in array elements are from 0 to n minus 1, and your push pop operation will be coming from this last position. That means from that very last position, just write in the reverse order, right? It will give you the reverse order, right? Other, if it is in the linked list, then define another stack and pop everything and push into the new. Then it will give you the reverse, right? Yes. Anmol, by changing the loop limit beginning from the last, and it can only be done for the array, right? But it cannot be applicable for linked list. You have to use another stack, or somewhere it will be stored. Everyone will be popped and put into the last. So sir, if we are using recursion in binary search, we have to use the same divide and conquer algorithm. So I think for computer reversion, no, right, divide and conquer algorithm. Here actually see, conquer term is cannot be used for binary search. Everywhere in बहुत सारा बुक है जिसमें ये बाइनरी सर्च वो डिवाइड एंड कॉन्कर के चैप्टर में दे देता है. That is not actually right thing. Actually, it is a divide algorithm. Conquer means, what do you mean conquer? Means combining the result, and it will give you the ultimate result of the large problem. Large problem will be subdivided into two disjoint part. Divide and conquer means disjoint part. It should be, right? It must be disjoint. So disjoint part, and the result of those two disjoint part will be combined, and it will give you the result of the previous one. That I am telling you one example. Suppose you want to find out the maximum of n elements, then I'm telling you the recursive form. That you take the first n by 2 elements and find out the maximum, and last n by 2 elements and find out the maximum. And among those two maximums, you have to find out the maximum of maximums, right? That will give you the ultimate maximum value of the whole array. That means those two results will be combined, and it will give you the ultimate result of that whole array, right? So binary search is actually divide algorithm. It cannot be said conquer. But erroneously, it has been written in many books. Those books are not actually authentic books. So that is the main idea is here for binary search is, as they can be divided into disjoint sets, and ultimately it cannot be combined. You are always pruning some list, and you are taking care of only the half of the list. So we are not combining in binary search. Do you understand, Sovipoda? What I want to tell you, that it cannot be combined. Only half of the list will be taken care of for the next search, right? It can. So it is called the divide method, and that's why it is. And as it is disjoint, no data will be common to both sides. That's why the complexity is same. But for finding nth Fibonacci number, it is not same, because in the right subtree F2 is there, in left subtree F2 is there. So many things will be there on the both sides. So you have to take care of all those things, right? Sovi Podar, can you? Is it clear to you? So you don't tell it is conquer algorithm. For finding maximum or minimum of an array, it is divide and conquer, because you have to declare this is the maximum of all those array elements. Then you have to combine the results. Conquer means combining the results, and you will get a greater view, right? Okay. Any more questions?
Already 40 minutes is over. Thank you for joining here. Nice questions. Just always remember that definitely you have to write your roll number here, but that is not necessary. Please come here to discuss something with me. If I'm not knowing about your question, that like today Bitcoin and what. So before that, tell Bitcoin that is not knowing to me. Please explain Tower of Hanoi once. I tried to understand Bit, could not understand Almond Raj. Why you are why it is not clear? Towers of Hanoi. The Towers of Hanoi problem. Acha, do you understand that when three pegs are there, A, B, and C? Just visualize these things. I have no board today actually. Three pegs are there, and first peg. Acha, just wait for 30 seconds. I'm taking the board, then I'll tell you. আচ্ছা ইউ সি না এটা না এখন এইরকম টাইপের পেন তো হ্যাঁ না বুটান বারান্দায় দেখো তো হ্যালো okay please appear for the test through following link. You see, just I am giving you one thing. These are the three pegs, Anmol. Three pegs, and here already it has been discussed by Professor Dibbosri. These are the here. So one, your movement can be one at a time. This is A, this is B, and this is C. This is A, this is B, this is C. Now you see this. That is what is the designing procedure. You see this. I'm telling you. Just suppose there are n number of disks here. Right. N number of disks here. Number of disks is n. Then what you will tell? The n minus 1 disk. You see this. N minus 1 disk, top disk can be shifted to here. And this one disk will be shifted to here. And then that means this is the first step. This is second step. And this n minus 1 disk again will be shifted to here. Now we can tell that these three disks, this n minus 1 disk cannot be shifted here. So what you will do? This is the definition of recursion. Then again, that means this is your first design. That this, if we can do this, this n minus 1 disk can be shifted to here. If it can be done by us, then we can shift one disk to here, and then again it can be shifted to here. So it can be done. I don't know it can be done or not. So Tn can be written as twice T n minus 1 plus 1. Why I am writing this? Is it clear to you? You see this. N minus 1 disk will be shifted to here. How much time is needed? I don't know. That is Tn minus 1. And this one disk will be shifted to here. That is 1.
and again n minus 1 disk will be shifted to here. That is again the same as the previous n minus 1. So that's why it is twice n minus 1. So for n shifting n disk, if you want B, then how many computations will be needed? That is twice n minus 1 plus 1. Now using this, you just do the substitution. Now, can you tell me that if there is only one disk, then what is the time needed from shifting from A to C? That is only one, because that one disk can be shifted to here directly. So this is the only base value. So no B peg will be needed. So for this reconciliation, T 1 is equal to basically 1, right? Now solve this. This can be solved by twice. Again, it can by twice. This is twice T n minus 2 plus 1 plus 2. This is equal to 2 square T n minus 2 plus 2 plus, sorry, this is not 2, this is 1, plus 1, right? In the next step, it is 2 cube T n minus 3 plus 2 cube, 2 square plus 2 plus 1, like this. Okay, so ultimately you can reach to somewhere, if after some steps you will get a number. Just solving this. I am not going through this to solve this reconciliation. This is very easy. Do this up to n. Ultimately, if you reach to T1 here, then you can get a series. What is this say? This is a geometry series. You can find out that what is the design. But if this are that can be solved by you. I am not telling you the details, but if you can do this n minus 1 this shifting to here, then definitely this can be shifted to here, and then definitely by the same method this n minus 1 this can be shifted here. But I don't know. Then again apply this n, the same procedure will be applied for n minus 1, then it can be reduced to n minus 2, then it is n minus 3 up to this. When you are dealing about 100, then if you reach to 1, then you can find out, then it will go bottom up approach and you can find out the result. This is the recursion, and this is Tower of Hamilton. Okay, thank you for joining us. Is it clear, Arnold Raj? Okay, for today, bye. Hello. Okay.